Everyone's still awake.
I don't know. Is everybody still awake? Seems so.
Yes.
Okay. Can I plug it in here?
Yes.
We share it online.
Yeah, I'll switch like this. So for today, what we have for you is basically a number of speakers and presentations. Sure, of course. That we have selected from our works over the last years in the space of SBOMs. And today we really wanted to focus on getting some European partners here, which are working on SBOMs on related developments. So companies in Europe, which are basically developing some technologies that allow to manage, produce, maintain SBOMs. And so in this case, the first one that we have here is Rob van Kranenberg, who has been known, I think, for the last 2,000 years as one of the fundamental IoT specialists in Europe. And you're related to the company Asvin, Rob, but I'll let you to do that introduction yourself.
Yes. First, let's try to get
the slides up. Yeah.
But yes, I was basically interested in what is called now Internet of Things from about 1999, when I went to a conference in Linköping in Sweden that was called Building Tomorrow Today, Intelligent Information Interfaces. And there were about 300 or 400 European researchers in the framework of what was then called iCube and the disappearing computer, as it was then called. And I was for the first time seeing all these people who were working on trying to get the computer to disappear into the environment, which was basically the vision of Mark Weiser in 1991, when he wrote a text called Computer for the 21st Century. And then going back a little bit, if you can go back to the automation in the 50s, where we talked about factories and machines, and what we now call the edge was then only the edge, so it was an intranet, so all of these things were happening. Then you had IBM in the 70s with pervasive computing, and Xerox PARC with ubiquitous computing in the 90s. So basically, all the things that we have now, we had in the 90s. There were smart fridges, smart environments, smart mobility, but it was only demos because there was no cloud. So around 2000, the cloud comes up, and it becomes possible to have all these small projects who are only demos, because in 1980, a gigabyte of storage would cost about $191,000. So you couldn't really do the things that you do today. But this was around the moment when this changed from ubiquitous computing, pervasive computing, then Philips came in 2000 with ambient intelligence, to the Internet of Things. And it's interesting to see that it's the Internet of Things as a term that made it, that actually made it. And that's because it's not tied to one particular company. So ambient intelligence was very much Philips. So if you would be in the ambient intelligence ecosystem, you'd be in Philips ecosystem. Pervasive computing was very much IBM, and ubiquitous computing very much Xerox PARC. But the Internet of Things was coined by a product manager at Procter & Gamble, who came from RFID, and was basically now the term that is still that we still use today. But it has a long history. And now I'm trying to get the slides up. See if that's working.
Maybe the screen turned off. So you're able to see it before. Yeah, here we go.
Okay, so currently I work with Asvin. Asvin is a cybersecurity company in Stuttgart, in Germany. It has about 15 to 20 people, so it's not as big as the big company that has about 100 offices. I think, let's see if we were aim to get there. Today I want to briefly talk about distributed software bills of materials. I think I'm going to skip this because we heard this in the introduction. There's lots of attacks like for J, and there's regulators increasing requirements to implement security. This also we heard basically because of the UN regulations, the White House executive order, and the NTIA framed definition. We now have these regulations. And if you want to export to America or basically to the world at some point, you're going to have to think about the SBOM. It's becoming more of a requirement. Risks are going from individual fragmented to coordinated, and so we need a novel approach. And Asvin, the mission is to have a novel approach to track and trace the trust, reputation, and provenance of software in a complex automotive supply chains. I think the key is really here about trust and shared situational awareness of all you and your the people that are in your supply chain, in your immediate environment. So Asvin provides, based on decentralized DLT smart contract technologies, track and trace software components from original equipment manufacturers to installation updates in connected cars. We're basically focusing on cars. Provides real-time software bill of material, cyber risk monitoring, and risk mitigation compliant to regulation, and increase trust, integrity, and resilience by decentralized ledgers for all actors to the entire software supply chain. So basically the argument goes that you have development, that you have the SBOM, auditing and approval, distribution, over-the-air updates, and then you go into the edge device, which is basically the car. And all of these entities then go back to the Asvin platform and provide a track and trace report of software. So why a DSBOM, a distributed, decentralized software bill of materials? And we use a DLT, and a distributed ledger can be described as a ledger of any transaction or contract maintained in decentralized form across different locations and people, eliminating the need for a central authority to keep a check against manipulation. Distributed ledger establishes single truth, track the trail of software and multi-tier hierarchy, CVE vulnerability monitoring for cybersecurity risk, and popular SBOM formats. So we're in a project called Trublo, and in that project, the DSBOM supports suppliers and OEMs of connected devices to fulfill the regulations. And really it's about implementing a strong industrial demonstration of distributed ledger blockchain technologies, implement trust layers across software supply chain ecosystems, to approve the DSBOM with stakeholders from industry, the one tier supplier, the contractor, publish the results as open source libraries, and building a proof of concept with using the Elastia network, the Spanish network, to showcase a DSBOM for connected vehicles. So by use of blockchain and an ecosystem of suppliers can commit and exchange information of software used in connected components. The process of commitment is secured by blockchain protocols, and the information stored is trusted by the census mechanism. Information will be additionally stored by encryption methods for distributed computing to avoid the unauthorized access of security and IP relevant information. So by that, the entire software supply system can easily commit information about software and use of specific components and define the security and access level of information shared with other suppliers and the OEM, the original equipment manufacturer. So authorized parties can establish a continuous vulnerability monitoring whereby they check committed software against published CVEs and if IT projects are affected with software components installed. So this SBOM will extend existing research results on blockchain-based track and trace applications towards supply chain. Now, popular SBOM formats are SPDX by Linux Foundation, CycloneDX by OS Foundation, and software identification SWID by NIST. And this is a brief example of an SPDX example, where you can see sort of what it looks like and what it contains. Especially in connected cars, the dependencies and software dependencies are very complex. So you see the entire supplier, it's a supplier that supplies to the second tire supplier to the first, then that all needs to have to build into an OEM over the software update, and then only services one particular car, one vehicle, individual software batch, one configuration. What we found, what we use is graph analysis, graph analytics, to identify software supply chain risk and improve risk mitigation. So Asvin provides identify risk analysis based on identifying software components exposed to high cybersecurity risk due to supplier relations, real-time monitoring for CVE vulnerabilities, and supply chain attack path detection for risk mitigation. And this graph view looks like this. So you have an isolated view. If organization A detects an attack and informs the connected units, but in this case, it informs only A, B, and perhaps also C and H. There's no direct link between organization E. If we increase the context awareness, then it becomes immediately clear to E that organization that it receives information about the critical exposure of B via the attack graph BDE. So the attack graph BDE becomes immediately visible. So these are the types of things that we're looking at in building these graph attacks and trying to involve context in analyzing.
Can I ask a question?
Yeah.
So given I have this distributed responsibility of development on different levels, and assuming that I am the OEM, having responsibility for a car that is in the field, and then all of a sudden within your graph, I see that there is a vulnerability appearing in some part of my software due to this supply chain analyze mechanism. So I see that a tier 2 supplier has a problem in one of his components. What would be the impact? What could I do from a PCER perspective? Where's the benefit of knowing this?
Yeah, that's a good question. If there's not a response, or if there's not a kind of a joint response, it's kind of a similar question that there was last Monday when I was in a discussion on the new EUREPOC, which is a shared repository of attacks that's now being hosted by the German and then Danish foreign ministries. And Microsoft was also presenting, and this was all about trying to get people to share information. But basically then Microsoft representative said, what if I share everything with you? What can you do with it? What's the point? So notifying the issues without a procedure for response makes no sense. So I fully agree.
Yeah, especially for everybody who's there now, okay, there's something, but is not able to understand the impact.
Yeah.
I think it requires the mechanism to inform people in the upstream and the downstream about issues that happen and what you as a creator think about it. So I think that's an important part. Absolutely,
it's the key. It's the key part. Without awareness in itself is not really yes. It's not really very much. It cannot be a real goal. The goal should be to act on that awareness, and I think as we see people making and building SBOMs, we'll see much more work going into that direction. It's not only listing the dependencies and the vulnerabilities, but it's actually.
Do you see that more in sort of a posture management? In a posture management. So if anything happens, you have to have a script and build a script which is vivid, which is alive, which is adapting, which is relying maybe on artificial intelligence, machine learning, or whatever. But you have to build it with posture management anyway.
Yeah.
Because you have to adapt to law, local law, GDPR, and all the other things. And bringing that together is like bringing it into one big posture management, where you can say, okay, if this happens, this is what we allow or not allow, or this is what we do, or how do we pick this up, this thing? And your question is obviously very clear. You can see everything you want. If you don't do anything with it, what's the use?
Yeah.
So I think, as I understand well, because I don't understand everything, but it should be something that helps basically the end customer in the end.
Definitely. This
is what it's all about.
Yeah.
So if we can see that he's going to get into trouble, we should be able to avoid that. Meaning that it's not the customer that's going to be the one to react, because then it's too late.
Yeah.
But if you see it happening in the stream, what are we going to do about it? And that's not something that's defining you. You see, okay, we're going to do that. What are we going to do with it if we know?
Yeah. No, but that's true. We're at the beginning of this development, and this people will come up with your questions and as we do now.
And I think you mentioned it in the beginning. It's up to you to fill it in. So basically, what you say, we're going to have that, but it's up to you to say, okay, what are we going to do with it?
Yeah, but
what do we want to do with it? Because you can do everything you like, but you can live miserable for yourself as well, which doesn't mean making sincere.
Yeah.
So you have to be very constructive and very intelligently creative with it.
Yeah.
But if you have to fill it in yourself, then who is going to guide companies to do that? Because that is going to be a gap.
But that's, I think, also one of the advantages of having such a group, or building kind of a group in Europe for these developments.
Cyber Resilience Act is also relying on us to say, okay, what do we think about
exactly.
it? Right?
So
we're going to go free updates on CVE monitoring during 5 years. Are we going to do that? Well, I don't know. We're going to do that.
Yeah.
It's very expensive.
Yeah. So we're at the forefront of all these directives, and in a way, if you look at them in isolation, you sometimes despair and think, how on earth is this going to be sort of possible or happening? But if you look at them in a kind of a total view, you see that Europe is really clear about this digital sovereignty, and it's really moving in a direction of building not only a European kind of sovereignty, but also a digital kind of sovereignty. And I think the work that we have with GDPR, which was really ridiculed to a large extent when it came here, and it's now being implemented by numerous countries across the planet. So we're becoming a kind of norms and sets of values exporter in a way. That's exactly the role that the EU wants to have, to embed their values in these things. But sometimes there are these moments where a particular product or service, or how you want to call it, becomes like a hinge. So if you use it well, and if you add other things to it, the SBOM becomes like a hinge to a door or a key that you can use to also not only raise the shared awareness, but also try to raise these shared responses, try to build shared responses. I think that's really the key.
Excuse me, does SBOM, in your opinion, will guarantee that there is no vulnerability in the software?
No.
So the key part of all
Well, it's obviously true, but then the next thing is, of course, if, for instance, in the US today, your SBOM is not clear enough, or if it doesn't contain, let's say, the respective components which are needed to identify that specific vulnerability, then you might be in trouble as a company that provided this. Of course, if you dare indicate that your piece of software is basically built upon a number of open source components which might be vulnerable, and you indicate, okay, there's a list of known vulnerabilities, and you report them, and you say, okay, this is what has been done with them. So you can at least show that you've taken the necessary measures, then it should be better. But it's not black and white. But I think the same question applies for if you have a product that's been certified under the certification guidance and it still gets hacked. Who will be responsible? Is that the certification authority? Is the company that installed it?
Somewhere in the whole picture, I see that there should be somewhere in the cloud like a centralized awareness center that will be really able to feed all the SBOMs or manufacturers of vulnerabilities and be able to interact fast. At the end of the day, everyone has to identify on this side.
Mm-hmm.
It is not going to be effective.
That's true, but I think there's actually a number of complexities in there, quite a number, which are trying to be addressed. One being, it doesn't make any sense today for companies to try to go out and to follow all of the different CVEs or vulnerabilities from any device out there. So that doesn't make any sense. You only want the ones which are relevant to you. So if you know which assets you have, which devices you have, then at least you should be able to identify potential vulnerabilities on the basis of what you then get back in. But there's a number of systems that can help you doing that. It's definitely not perfect yet. But then the next thing is, if you have a system which is composed out of multiple different components, Whereas a vendor, you don't even know yourself, which is usually the case, what all of these subcomponents really are. Well, then again, you're being faced with the challenge of how can we do that? So there's a number of centralized systems which are actually decentralized, and the idea of the SBOMs in terms of centralization is called VEX, where it's sort of a distribution of different SBOMs. But that's not yet proposition. I think we can see the first things happening there. But it's an evolutionary path, that's for sure.
Can you compare that to MITRE or?
Well, yeah, so MITRE has developed a framework to be able to share. So the attack framework, the defend frameworks for MITRE. Almost to some extent, but it's usually more MITRE.
It's more on applications.
Yes, correct. Yeah. And also not directly in terms of sharing of the vulnerabilities.
I think that these type of databases are growing. We at Checkpoint, for example, we have our own threat cloud where we spread this news. So whenever we detect something in 2 seconds, the whole world knows it. And it's being updated in our system or via our systems, but also put available to our colleagues and other
which is the way it should be.
So this is the way to do it, because otherwise we cannot fight the criminal.
Absolutely. And so like you within Checkpoint, you also provide your intelligence in the MITRE framework.
And it's obviously a cloud. And this cloud thing is being fed by artificial intelligence machine. Like our buzzwords, but anyway, it just means that there's still somebody human that's pushing the button anyway.
Absolutely.
In the end.
But one great advantage of this, of using such a framework, and also same for SBOMs, is that at least you can say, okay, as a company, I'm using Checkpoint as one of my
it doesn't
network systems.
Even have to be a Checkpoint, and we can using another. But we make it available.
Okay.
So never there's another player, one of the 3 players in the world. So the others, everybody knows it as well. I mean, there's no secret about it. And I know Microsoft and AWS and Azure, they're also using some of our resources to implement it in their own cloud native security, which is basic, but they use it. So, and it's basically like two communicating vessels. So in that way, obviously we try to help, but obviously for SBOM is something, again, something specific, which is not really vulnerability as is. So it should maybe be something new, something extra.
Yeah.
I don't know how, if it's vexed, then yeah, sure. And a good thing to do.
Okay. Please continue.
Yeah, well, basically, so the business of the benefits of the distributed SBOMs, improve cloud-based transparency, representation of all the dependencies and the risk application. So it's not only foremost about vulnerabilities. I think it's more about dependencies. Dependencies that you've missed before because you haven't really looked at what this supplier or what this has been doing. Effective controlling unified safety framework. Yes, I think I will leave this here. So this is a company with Mirko Ross as the CEO of Asvin, and we have Rafael Jan at in Boston to look at this graph-based dependencies, and very much advisors from car manufacturers. And yes, you know this. Okay. Thank you very much.
Right. Rob, if I may ask, you introduced the concept also of the distributed model. So it's basically a concept of using distributed ledgers then to also record what's happening into the SBOMs. Have you been experimenting with that, or are you using some real life cases already in that space?
We're experimenting with it, and we're using some real life cases in this True project.
Okay.
It's one of the ways of working. So it's not really opposed to, like, let's say, a centralized approach. Or I think it's ways of working that will happen more. So it's not really that as there's huge advantages or huge differences. It's a way of working.
And so, how then, in practical, would you see that happening? Is that through your system then? That basically somebody develops their SBOM and then they report it into the ledger on your side, or how would it work?
I think that's one of the ways it could work. And another way is that we co-create the SBOM. So we help people building their SBOM.
Okay. And then you would record all of the different elements in there, which then go into the ledger or something of kind. Okay.
Any question?
A question. I mean, the aim is great, but when I think about all these operational little issues that are in the real world, I feel it's, from my experience, it's pretty difficult to maintain the relation from the SBOM to the binary, which is actually describing, and especially when it comes to taking the binary or the result, let's say, that's produced. It must not necessarily be only one binary. It could also be a huge sum of binaries, or that's addressed by the solution, which is then described by the SBOM. The SBOM is external. It's somewhere. It does not come to this particular piece of executable that is somewhere and executable. And you aim to understand where it is operating in your supply chain view. How do you fit all these things together?
I must say that we're working on these issues. So this is not something that we've got all worked out. So on the one hand, I think we're maybe complicating or overcomplicating things, but on the other hand, I think this is a time to experiment with different ways of operating. And I think, as you mentioned with your remark and question about awareness is not enough. Fully agree. And here the fact that you use a distributed approach, so that it must have an edge at some point, because otherwise it would just be an overcomplication at some point. So it's all work in progress, sort of.